Welcome to EELE 367 Logic Design. My name is Brock LaMeres and I will be your instructor for this fully online course being offered by Montana State University during the summer of 2023. The purpose of this video is to give you an orientation to the course, show you where the learning activities and the learning materials are, and get you in a position so that when you're done, you can engage with the activities of the course and start making progress. All right, let's get started. Let's begin by looking at what this course is about, all right? And so to do that, it kind of helps to look at what the prereq for this course was, which is 261 Introduction to Logic Circuits, okay? Now, in this class, what we did was we covered the building blocks of a computer, but we just started at kind of low-level stuff, okay? So we breadboarded stuff, looked at AND gates, OR gates, combinational logic circuits, and we covered 7 modules. So we looked at analog versus digital. We had to figure out how to use ones and zeros to create numbers. We looked at basic digital circuits, so what an AND gate and OR gate actually are in the real world, power supplies, grounds, logic levels, etc. Then we finally started looking at combinational logic design, which was where you take descriptions of logic from a truth table and you actually synthesize the logic. So products of sums of products, and we looked at minimization using K-maps. And then we kind of stopped because we got to the point where even the combinational logic circuits were getting so big that it was better to start looking at the modern digital design flow. So that's where we took a break and went into Module 5 and introduced the hardware description language, VHDL. And we just did some, cursory stuff of like, okay, let's just do a simple combinational logic circuits with VHDL. But even with just a little intro, we were able to build a relatively large combinational logic circuit. And then we looked at medium scale integrated circuit logic, so things like multiplexers and demultiplexers. And we built those in VHDL, and they were pretty straightforward. And then we wrapped up by looking at sequential logic, which is where you have the notion of a storage device that is synchronous to a clock, and you could build finite state machines. Okay, and then we did one final VHDL, circuit that kind of built that, but we just did it by like wiring up D flip-flops in VHDL. Okay, so what's this class? We're still looking at the basic building blocks of a computer, but this time we're going to do it all in VHDL, okay? So everything's too big now to do anything by hand, so you have to use the modern digital design flow. So that means you're in the tools. You learn about the concept of what this system is, then you learn how to model it in VHDL, then you simulate it, and then you synthesize it, and you test it, and you look at whether it's working. So in this class, we actually do 6 additional modules. We start by looking at Module 8, which is VHDL Part 2, and that describes the rest of the language. So we only covered a little bit in the prereq for this. In this one, now we start looking at the rest, right? So different libraries, different data types, different ways to model logic. We look at the process, and we look at test benches and self-checking and all that stuff. And basically, we round out all the different functionalities we need to describe a modern digital system, such as a computer. Module 8 is where we just go model a bunch of stuff that we're using these new techniques. Module 10, we look at actual memory systems, so not just D flip-flops, but actually memory arrays like SRAM, DRAM, basically ROM and RAM. And then we finally get to the point where it's like, okay, now we finally understand what programmable logic is, or we can at least learn about programmable logic, because we implement everything on FPGAs, field programmable gate arrays, but we don't even know what's going on under the hood. And it's not even until you get through all those modules that we can actually stop for a second and go, what is an FPGA? So you finally understand all the details of what's inside. So like LUTs and BRAM and all that sort of stuff that you learn about. Module 12, we finally look at arithmetic circuits. So we look at like adding and subtracting. And it's interesting because some courses cover adding and subtracting really early, but we don't in this class because adding and subtracting needs to be done in VHDL. So you have to have the modeling techniques before you can actually learn about them and build circuits right away. There's no sense building a 4-bit unsigned adder just because you can. It's like, let's just wait and then rock it all out in Module 12. Then Module 13 comes along, and this is at least 25% of the course. This is the culmination of everything you've done. You build a full computer from scratch, and you will program this thing in ones and zeros, and you will pull everything together that you've ever learned about digital logic, and it is awesome. Okay, so that is what the topic is of this course. Okay, So now let's look at how you engage in the learning activities and what you actually do. So everything in the course starts with Brightspace. Brightspace is the course management system or learning management system. You'll hear it called LMS. Sometimes you'll hear it called Desire to Learn. Desire to Learn was just the name they used to call it before. Now it's called Brightspace. But anyway, you go to this ecat.montana.edu and you log in with your net ID and password. If you're not an MSU student, you'll be given one of these to log in, but it's one login for everything. When you get here, you come to your landing page. You're going to go down on the bottom right and you're going to see this My Courses widget. Go ahead and scroll to 2023 summer session, and then you'll see all the courses you're enrolled with. So when you scroll down, you'll see Logic Design, EELE 367. Our section is 801, meaning it's an online class, and then it's 2023 the year, and 50 means summer. So just in case, I don't know why you'd ever have multiple versions of the same course. But anyway, click on that thing and that brings you to Logic Design. So you see our landing page right here. And so what'll happen is that when you come down here, you'll probably see some announcements for the week. I have announcements set up that'll come, tell you what we're going to do for the week, and then they'll go away at the end of the week so that you don't have this cluttered view of it. But when you come into here, there's all these tools across the top. But what I do is I link everything in content. Okay, and I'll show you what that means. So within content, you have these pages, and the pages correspond to every module in the every module that we're going to cover. All right. And that's where everything is. So like what I mean by that is if you go to course information and syllabus as an example, this is where you start. Just a little intro of what's going on. This is where you're going to find the syllabus. This is where you're going to find your first assignment, which is a course overview quiz. If I click on like course syllabus, it pops up the document. If I click on course overview quiz, it pops up the course overview quiz. What I mean by everything's linked is that you can get to things up here. Like you can get to all your quizzes here, and you can get to the assignment folders that you'll upload to here. But I linked everything in the pages. So you can always know that everything you need to get to is in the pages. So you don't have to worry about knowing where things are in the class. Everything's on the page. All right. On this particular page, you're going to come down here. You see the contact info for me. You see content info for Ben, who's our TA. You're going to get to know him well. Professional email etiquette guide. And then you've got your link to the book that I wrote. This book is what we used in 261. 261 was chapters 1 through 7. We're covering 8 through 13. Amazon is the best way to get it. I don't have it at the bookstore. It's cheaper at Amazon. And so this is where you access all the information. All right. So let's look at the syllabus really quick to get a feel for what are the deliverables. Okay. So let me come over here. Here's the syllabus, description, outcomes, instructor, content, time, all that stuff. What you need for this course is a computer running Windows, and we're going to use VHDL tools. We're going to use Quartus, and we're going to use ModelSim. They don't run on Macs. Okay, so if you have a Mac and you can't get access to a Windows machine or a Linux machine, you can't take the class. There's no way around it. So you can't be an engineer with a Mac. I mean, I'm sorry. Okay, get rid of your Mac and get a Windows machine or a Linux laptop. Okay, and then you need the textbook by that little fella, and then you need a portable lab kit. This is really important. You need to check this out right now. Okay, so we were trying to get everybody at MSU to pick these up during finals week. If you haven't picked it up, pick it up today. If you're not in town, you need to get me your address immediately so I can ship this to you, because we have deadlines that are due right away. The way you're going to demo your labs is actually taking a short video of your circuit working and then uploading it to an assignment folder. So everybody has a phone, so that's what everybody does. But I put in here a camera capable of taking short videos. The prereq is 261 or equivalent. If you're at a different school, you should know what a K-map is. And if you haven't touched on a HDL, you could probably catch up just by going through the book, chapters 5, and you should be okay. The way that the course is going to be broken down in terms of assignments is you're going to have 15% of your homework, 45% are labs, that's where all the learning is, 20% is end of module quizzes, and then 20% is the final computer project. Okay, so almost all of this is just labs. So 40, the labs and the final project is you are just putting stuff in hardware and VHDL, and it's awesome. Grading is straight, 90% is an A, 80% is a B. Academic policies, you basically don't cheat. What cheating means is that if you turn in somebody else's work, if you collaborate with other people and help other people, that's great. That's how the world works. But if you turn in their work, the world falls apart. Okay, that's cheating. Whatever. Course components. It's very important to understand that I developed the course first, then I wrote the book, and then I made the videos. So the book and the videos are identical. Okay, so if you like to read, all the information's in the book. If you'd rather watch videos, all the information's in the videos. But if you want to switch back and forth, you can. So it's different modes of delivery. Homework is due every week, and it's either going to be in the form of a multiple choice quiz or a VHDL simulation that you'll take screenshots of and then upload your code. All right. When you open up a multiple choice quiz for homework, you can do it as long as you want up until the deadline. So you can open it, save it, reopen it later. Lab assignments are where you're going to spend most of your time. You're going to be coding in VHDL. You're going to be putting it on the little FPGA board. You're going to be blinking lights, reading from switches. Those are due every week. And then you're going to have these end of module quizzes. There's 6 of them. These are multiple choice quizzes, and they're meant to emulate it like an in-class exam. So they're timed. So if one of them might be 30 minutes. Some will be an hour and a half. But you hit go and the clock starts. Okay, so you can't like start them, log out of Brightspace, and come back the next day. Once you hit go, you have to finish it. So these are meant to be kind of like an exam. They're not terrible, but I just want to make sure you have to do it in a time period before the deadline, so you can do it whenever you want. Then there's the big old final project that's going to be 20% of your grade, and you're going to build a full-blown computer. This is your guide to the class. This is really probably the most important thing in the syllabus. It is the breakdown of everything we're going to do each week and what's graded and what's not. So whenever you see points over here under the homework, lab, quiz, or project, that means there's points that you have to do and there's a deadline. The deadlines are always at Wednesday at noon. During the first week, I need you to do some activities that are due right away, the first Wednesday, 5/17 at noon, just to show you're in the class. I need you to make sure that you can do the quizzes and that you have Model Sim downloaded and you can actually show that the tools are installed. Then some of the activities for week 1 are due the following Wednesday, and that's how the flow works from then on out. So as you come down here, week 2, you're going to go through material, watch videos, do reading, do homework, do the lab, do it, and then it'll all be due the next Wednesday at noon. The idea is that you can work through this during the week, but if you need the weekend, go for it. And if you need help after the weekend, you got Monday and Tuesday to get help. Okay, so that's where the Wednesday justification came from. I never have deadlines outside of working hours. It's a disaster. So everything goes wrong at midnight. So all the deadlines are always right in the middle of a work day. All right, so then you just lather, rinse, repeat. Every time you come to the end of a module, there's a module quiz. But a module doesn't correspond to a week. For example, module 9 takes 4 weeks to get through, or 3.5 weeks. And you only get to the module quiz in week 6. Okay, but again, this week's activities, week 3, are due Wednesday at noon of week 4. Week 4's activities are due in Wednesday at noon of week 5, etc., etc. And you just crank through here. One thing to note is you'll see not everything has the same point value, and that's reflected in like what's a multiple choice quiz and what is a VHDL simulation. So for example, 9.1 and 9.2, these are homework assignments. They're only worth 3 points. Those are multiple choice quiz. They're not terribly difficult. They're just basically testing you on terminology. But 9.3 is 14 points. That is a VHDL simulation. That's going to take some effort, and you're going to be coding and debugging, so you get more points for it. The labs are worth a lot, right, relative to the homework, because you're putting stuff in hardware and you got to spend time on it. So when you look at a week, what you should do is kind of look at it and get familiar with like what points are assigned and plan accordingly. So for example, on module 9, you've got 2 multiple choice quizzes. It's like, okay, probably not going to take that much time, but you've got a lab. So that's where you're going to spend the bulk of your time. Week 4, you got a VHDL simulation homework. So it's like you got to split your time better on that one. Come to module 6, you got like a little bit of time on the homework, spend the time on the lab, and then you got like a little homework, big lab. Okay, so just time yourself accordingly. You can see once you get to the computer project, it's basically we chip it into a bunch of different parts. So you have a couple terminology assignments, and then it's like part 1, wire the whole thing up. Part 2, add the logic to perform 4 basic instructions. Part 3, put it into hardware. Part 4, add more instructions. And there's a whole write-up on the project on that. Okay, so that is how you engage in the the actual course. Okay, so let's take a look at a representative content page as we wrap up, and then I just want to show you the lab manual so you can see pictures of what the hardware looks like. So here's a typical module, module 9. You come in here, you've got, it's all broken down by topic. So it's section 9.1, 9.2, and then you do a lab, 9.3, 9.2, or do a lab. So the deadlines aren't on here, okay? The deadlines are in the syllabus. So you work through this material based upon the schedule and the syllabus. And so when you come in here, you're gonna be like, oh, here's a video. So you click on the video, you come in here, and lo and behold, there's a video, and you sit there and you're like, what's a video like? You're like, da-da-da. It's like, oh, there's me. So it's me sitting there coding away. Almost all these, I'm drawing and I'm coding and I'm doing all this stuff, and you just kind of code along with me and follow along with me and take notes, or if you're coding, just code. And then you come along and you see like a homework assignment, 9.1, that's going to be a quiz, right? So it's linked in there. You can start it and you just click in your answers. Life is good. But then you get to the labs, and the labs are really cool. I give you a lab video. I give you a lab description, but one thing to note is that the lab description is a huge book. So it's 200 pages. That has all the labs in it. So you only need to download it once. So let me go to like lab 9.1 and show you what it looks like. So like here's a typical lab. You're going to build this thing called a ripple counter. And I give you all the learning objectives and what you're going to do. And then I give you the block diagram of what you're going to implement. And I describe what you're going to do. But this is going to go on hardware, okay? And this is the hardware you have. So you're going to have a DE10 Lite FPGA board. This is an Altera, now Intel FPGA. And you're going to put your VHDL on there. You're going to synthesize for it using a tool called Quartus. And then you're going to run it. And you're going to have buttons and switches and LEDs. And you're also going to have this thing called the Analog Discovery. This is an instrument that can provide power. It can read logic signals. It's an oscilloscope. It's everything. And we're going to use this to observe things coming out of your actual system. So when you get done with this, you basically are just going to take like a video of your thing working and upload it. And what you, at the end, or each lab is very specific about what the deliverables are. So it starts with the deliverables, okay, and it tells you how much they're worth. So 70% of the exercise is a video of your circuit working. 20% is the logic analyzer measurement. 10% is your code. Okay, so that's where all the learning really happens, and it's awesome. I'll be honest with you. When you do this computer, it's almost a life-changing event because it's the first time where you're like, holy cow, I understand how a computer works. Up until the time you build a computer, you don't know how it works. It's so abstract, and you're just like, yeah, I know what a flip-flop is, and I know what C code is, but how does it all go together? And you're programming the thing with hex characters. You're like, F0, and the thing will do something, and you're like, wow. So anyway, that is the course. Okay, that's what it's about. That's how you engage on it. So at this moment in time, here's what you're going to do. Make sure you got your lab kit. If not, go get it. If you're not in town, email me your address immediately. Then start going to the content page and start working through the deliverables. Get that syllabus ready. Get familiar with the table and just start knocking things out. If you want to work ahead, go for it. You can work ahead. You just can't work behind. Okay? All right, life is good, and I look forward to working with you.